Good morning, everyone. Today we will see branch and bound technique for solving problems in algorithm analysis. Branch and bound technique is mainly used for solving optimization problem. Optimization problem has two types. There is only maximization problem or minimization problem. For maximization problem, value should be maximum. Maximum value is the optimal solution. For minimization problem, minimum value is the optimal solution. Here, the problem is divided into number of sub-problems and solve the sub-problems level by level. Branch and bound techniques solve the problems in multiple levels. And each and every level, we are finding the local optimal solution. Either maximum or minimum value is optimal. Each and every level, the local optimal value is expanded to the next level. Other values are eliminated or pruned. So, this optimal subproblem can be expanded to the next level to get final global optimal solution. Here, this is a systematic design technique used in artificial intelligence, operational research, and mainly used for solving combinatorial optimization problems. Here, it explores the search space of all possible solutions by dividing into smaller number of subproblems, that is called branching. Then users bound on the optimal. Bound means either maximum value or minimum value. That is selected for expanding to the next level. It is called bounding. And this approach helps to find optimal solutions without exhaustively searching the entire solution space, which can be crucial when dealing with large complex problem. If the problem is too complex, if you are searching all the possibilities, it will take more time. That is exponential time complexity. To avoid this, we can expand the problem in multiple levels. At each and every level, the optimal solution is selected. That's called local optimal. That can be explored to the next level. And to find optimal solutions for complex problems, branch and bound strategy is applied. It divides a problem into a number of subproblems. Here, the problem is represented in the form of tree structures. Here, we have the root node, that is initial solutions. Then the first level, all branches are all possible solutions of subproblems. So in the first level, all subproblems are solved. We are choosing the best one as a optimal. For minimization problem, which node has a minimum value, that is optimal. For maximization problem, which subproblem has a maximum value, that is optimal solution. That is called local optimal at particular level. So that optimal solution is selected, that can be explored to the next level. That is called branch and bound technique. There are four important operations are performed in branch and bound strategy. First one, exploration. Second one, branching, bounding, pruning. So we will see one by one. What is branching? The problem can be explored in the tree with all possible options or subproblems called branching. So we are taking the root as an initial solution. So for the next level, we are taking all possible combinations or we are taking all subproblems. We are solving all subproblems at a particular level. This is called branching. Then we have multiple subproblems and solutions, and we are choosing the best one. That's called bounding. At each level of a tree, bounding function is applied to find the solution of all subproblems. The best solution is explored to the next level to get optimal solution. So choosing the best solution at each level is called bounding, either lower bound or upper bound. And what is pruning? At each level of tree, only one optimal is chosen. The remaining nodes are removed or can be pruned. That is not explored to the next level. It's called pruning. And what is exploration? This approach explores all the possibilities and performs repeating branching, bounding, and pruning till optimal solution is found. So the problem is solved in multiple levels. Each and every level, we are choosing the best one and we are exploring. These processes repeated till we have the complete solution to the given problem. This is called explorations. So these are the four important operations performed in branch and bound strategy: branching, bounding, pruning, and exploration. And this is mainly used for solving optimization problem, either maximization problem or minimization problem. The problem solution is represented in the form of state space tree, where each node is represented a partial completion solution. So solution to the subproblem. This final leaf level, the last level, the node has a optimal solution. And how we can search for the uh, optimal at each level, how we can expand it. So that is called searching strategy. Here it use breadth first search or depth first search. It can keep track of all the best solutions found so far and backtrack whenever it encounters a node whose bound is worse than the current best solution. The algorithm terminates when all possible paths have been explored or pruned. And we will see the approaches for solving branch and bound technique. There are two approaches: breadth first search and depth first. Breadth first search means we are solving level by level. It's called BFS. What is DFS? Moving one path or one solution path and find the result, then move back to the another possible solution path. That is called depth first search. So we will see some important points that differentiate both BFS and DFS. Search order. So what is breadth first search? This is level by level, breadth wise. First, explore all the possibilities at one level. Then go to the next level, next level, next level, level by level search. But in the case of depth first search, explores as deep as possible before backtracking or finding the solution. So it moves only in a one path till we get solution of dead end. And what type of data structures we are using in BFS? Searching strategy is first in, first out. Q is implemented as a data structure for implementation. And in DFS, last in, first out. Stack is used for implementation. Here, DFS uses backtracking. Backtracking is implemented with recursive approach. So LIFO stack recursion is used in depth first search. And memory usage. Here, in BFS, it stores all sibling details at the current level. So it needs more memory. But in the case of DFS, it has details about only one path, so it requires less memory compared to breadth first search. Pruning efficiency. Prunes yearly if good bounds are known, because it will do line by level by level. So at each level, pruning is performed. Only one subproblem is selected as a local optimal. So pruning is efficiently performed in BFS. In DFS, not pruning is efficient. It will do depth wise. If it is not feasible, again go back another possibilities. So there's a poor quality of solutions before pruning. So it's mainly BFS is best for finding optimal solutions first, and DFS quickly finding a feasible solution, not necessarily optimal. So example is zero one abstract problem for BFS. In DFS, traveling salesman problem, it used the concept called backtracking with recursion. And what are the advantages of branch and bound? It guarantees optimal solution, because unlike heuristic approach, it always find the best possible solution at each and every level. So it leads to finding a global optimal final solution. So this is the advantage of branch and bound, always getting optimal solution. Next, second one, efficient pruning of search space. So we are solving problems step by step. Each and every level, only the local optimal solution is taken for exploration to the next level. Remaining subproblems are pruned. So that saves the time. Time complexity can be reduced by applying pruning in search space. And third one is applicable to both minimization and maximization problem. So mainly branch and bound technique used for solving optimization problem. It can be minimization problem or maximization problem. So lower bound is calculated for minimization problem. The problem solution which has minimum lower bound value, that is the optimal at the current level. For maximization problem, which sub problem has the maximum local optimal solution, that is called maximization problem. And handles complex problems. It's mainly effective for solving combinatorial problems. For example, zero one abstract problem. And examples, zero one abstract problem, traveling salesperson problem, that is to find the shortest path from one city to another city. This is a minimization problem. Traveling salesman problem is minimization problem, finding the shortest path between two cities. That is called traveling salesman problem. And job scheduling. There are n number of jobs, and assign the person to the job with the minimum cost. It's called job scheduling. And integer programming, linear programming, finding the maximum is a, objective values with some constraints, or minimum value with the constraints. So we can solve objective function equations using branch and bound technique. And gate puzzle solving problem with minimum cost. These are some examples in branch and bound technique. And main thing is time complexity. This the worst case is exponential, because it explores all possibilities at each level. So the time complexity is order of b power d. What is b? B is branching factor. Number of branches at each level is called branching factor. What is d? Depth. Number of edges between the root node and the leaf node is called depth of a tree. So that is called depth. Number of edges from root to the last leaf node is called depth of a tree. So these problems, branch and bound problem, time complexity is based on branching factor and depth of a tree. So order of b power d, b is number of branches and d is depth of a tree. Thank you.